Quasars are known for their intense bright emissions, and they are relatively small, much smaller than most of the stars out there, and they can outshine galaxies. Our Milky Way, as an example, they can shine up to 1000 times as bright as it. Another interesting thing about quasars is that they are in the region of the space which is very far away, and when you look so far back in space, you are also looking so far back in time. This means that most of the quasars we know today are very old, and most of that what we observe in the space are actually 13 billion years old, just formed only 600 to 700 years after the Big Bang. So here's everything you need to know about quasars. Intro. The quasar actually stands for quasi-stellar radio source, and the reason why it has this name is more related to its history rather than the radio emissions which the quasars emit. Now, the discovery of quasars began in the late 1950s when radio astronomy emerged as a new branch, and this unlocked a whole new potential for the scientists and astronomy. Now, when scientists looked at different objects like stars, galaxies, and nebulas, they also found some objects which defied explanations. Scientists were puzzled about what these objects are, and when they observed their angular diameter, their brightness, and their resemblance to stars, scientists assumed that these objects are actually in our own galaxy. But when other astronomers looked through the optical telescope, they didn't find it. And this didn't make any sense. So the stellar spectrum was collected, and their spectral lines again didn't make any sense. They were too absurd, predicting the elements which shouldn't exist. Some of them changed their luminosity very rapidly in the optical range and even more rapidly in the X-ray, suggesting an upper limit on their size, perhaps no bigger than our solar system. Now, this spectrum was actually explained by the fact that the light from the source was actually too redshifted, indicating that this object is somewhere very far away. As a result, these objects were named quasars, quasi-stellar radio source, for their intense radio emissions. Today, quasars are actually thought to be part of AGNs, the active galactic nucleus, and they are thought to be the young galaxies, powered at the very center by a supermassive black hole. Now, this intense brightness which we observe about quasars is actually due to the black hole itself. How ironic. Now, black holes themselves do not emit any light, but with their surroundings, it is a completely different story. The accretion disk of the black hole is actually full of clouds, dust, and everything you can imagine. So you can imagine the intense pull of the black hole and how fast the objects would revolve around it. Now, the edge of the black hole is called the event horizon, and it is the point of no return. Anything that goes beyond it just doesn't come back. But for the opposite side, the things which are revolving around it are actually revolving in like hell. Because of this intense gravitational pull, the particles are actually accelerated almost as fast as the speed of light. And because of this, there are intense collisions, and because of these, they collide, lose momentum, release energy, and as a result, they emit these highly powerful and bright emissions. Galaxies today again are also powered by the supermassive black hole at their center. Our galaxy Milky Way have Sagittarius A. This is a bright spot which you can observe with your very own eyes in the night sky. These are not considered as quasars, and they are neither as bright. But we do not find quasars in the region of the universe which is close to us. Now, the possible answer for that is that the quasars which we observe in this space are actually from the very early phase of the universe. So, because of this, the part of the universe which they are from could have much higher matter density than what we have today. Also, in that part of the universe, there was so much more matter in that place for the black hole to feed upon. So as this black hole sucks in the matter and the accretion disk of the black hole heats up, it produced these intense bright emissions in X-rays, radio emissions, and the visible light that had outshined an entire galaxy. But keeping in mind that this is not the brightness which we observe in our telescopes because they are really far away. Today we also have a category of galaxies which have bright centers, and they are called Seyfert galaxies. Now, these galaxies are also part of AGNs, but these galaxies have well-defined structures and quasars don't. Here's an image of Messier 77. Apart from that, even today quasars are still very hard to study because again they are so far away and we really can't know much about them. There isn't much to observe on apart from their really bright centers and their radio emissions. So there's nothing to push into. But again, it is a part of the universe which lets you study the very early phase of the universe. So that is it for this one, and I hope you guys enjoyed it. So I'll see you guys in the next one. Till then, goodbye. I'll see you later.